In this video, I want to show you how to set up a bore gauge for quick measurements of an engine. So the bore gauge comes in a kit, and the kit is going to include the gauge itself, which is essentially a dial indicator, but the measurements are made based off of the arm. And then it's going to have a series of different size and length adapters so that you can make it work in pretty much any size cylinder bore. So the engine we're going to set up is a 2011 2ZR and the standard bore. So I always look up the new, what a standard size is. So the new size from a new block would be 3.1693 inches. So to start, we're going to take a micrometer that matches the range. This is a 3 to 4 inch micrometer, and I want to make it to 3.1693. So there is 3.1, 3.25, 3.15, 3.69, and vernier we have 3. So 3.1693 is measured there. And then I'm just going to place this in a vise because I need to have kind of both hands to do the rest of this procedure. So a little cloth rag there to keep it from damaging my micrometer. And then when I select the sizes, just like when I'm setting up the dial indicator, like measuring a rotor, I want to make sure that this centerpiece, which is the one that actually does the measuring, is preloaded to about half of its distance, give or take a little bit. I don't want it way far out, and I don't want it way far in. So when I go to set it up, that's what I'm going to be looking for. And you just pick the sizes that you want. One thing to always remember is that you want this piece to be on the back side of it. This is, you can see it's a rounded edge. So that way I don't scratch the cylinder when I go to install it. So that's going to always be the back end. And then, so we're just going to take a guess here at size number 4. Now the trick is to install this. This is why you need a couple hands to install this, and then once I do, I can zero it. But you can see that this particular size ends up with the measuring tool too far inside. So we're going to go to a smaller size. Okay, once I have the right size, I'm going to put this in the micrometer, and I need to hold it still. And then what I'm going to do is zero this. And now that it's zeroed, when I put it in the engine block, anything that shows 0 is my standard size, my 3.1693. And that way I can quickly go from cylinder to cylinder and measure it. And if I end up with a little bit higher or lower, then I understand that that's where what my sizes are going to be. Now that we have the bore gauge set up for the standard size of the cylinder we're going to measure, I'm going to insert the tool, and I'm going to measure for wear on the thrust sides of the engine. Now the thrust sides are going to be the side-to-side motion, basically from the force of combustion. That's where most of the wear is going to take place. So as I put the tool in, and I'm going to tilt it, rock it back and forth, and I'm looking for that gauge to get to its lowest number. And it gets smaller as it goes in the counterclockwise direction. And when I find that smallest number, then I can, basically it's going to tell me that my tool is going to be perpendicular, and I want to make sure that it stays perfectly perpendicular to the top of the block. So once I do that, then I can take my measurement, and on this particular measurement, I see that it's about 2/1000 of an inch greater than our standard measurement. So if I Originally had 3.169. I'm going to add 2 thousandths to that number to end up with 3.171. You'll notice I dropped the 10 thousandths place on the number. Originally we set it up at 3.1693. This tool does not measure in 10 thousandths of an inch, so it's kind of useless for me to keep that on there. So I'm just going to use to the thousandths place, and so my measurement, the 3.171, would give me wear for this for the top of the cylinder. Now, as I move the tool down to the bottom of the piston travel, I'm going to take another measurement here, and I can compare that number to my first number to determine if the cylinder has any tapering. And in this case, I'm measuring about 3.170, so I have about a 1/1000th of an inch taper on the cylinder. And then I can move to the non-thrust sides and take another measurement here and compare this to my thrust sides, and this will tell me if the cylinder has any ovaling or outer roundness. And I know you can't see it, but in this measurement it was 3.171, so it was the same as our first measurement, so no outer round exists. Now the beauty of taking the time to set this tool up is that I can very quickly move from cylinder to cylinder and compare and make sure I don't have any cylinders that are way out of spec, or if I just need to throw the block away. So that's why we take the time to set it up initially. Now there is one precaution I want to give you. When you insert the tool into the block, tilt it forward and rock it back into the block, and that's going to help keep from damaging the tool or the cylinder. And then avoid snapping it as you're bringing it out. You don't want the gauges to snap closed very quickly. That can throw your zeroing off, and so your future measurements can be skewed because of that. But other than that, like I said, it's just a bit of time to initially set it up. But once it's set up, the measurements go very quickly, and you can very easily determine the condition of the block. So that is your bore gauge.